Hi everybody. We're going to talk about graphing a trig function by hand without a calculator. You don't need a calculator. And I'm just going to be talking about the sines and cosines. And I do apologize if this gets a little bit kind of off track. You know how things go when I make my videos. They're pretty interesting at times. I'm just going to make one up and go from there. Y is equal to 2 plus 3 times the sine of, let's say, 2 times x minus pi. Alright, now, there is an A, there is a B, there is a C, and there is a D. A, B, C, and D. A is this value right here. There's B, there's C, and there's D. Now, if we look through these different parts, A is 3, B is 2, C is 2, and D is, remember this argument right here is x minus D. So we take a look at the opposite of what this is, and this is pi. Now, A is equal to the amplitude, so that's going to affect my minimum and maximum values, and I'll show you an easy way to do that. B, I can take this and plug it into 2 pi over B, which would be 2 pi over 2, which would be pi, and this is the period. How long does it take for the sine function to complete one cycle? That's what we want from there. 2 is my vertical translation. Basically, this is going to affect my midline, where all the zeros are. And by zeros, I mean, think back to algebra. Zeros are where the axis or the graph intersects the x-axis, and pi for D, that's going to be what we call phase shift, which is just a horizontal translation. And this is just the same as any other function. We're going to be able to move things up, down, left, right, compress it, expand it, that type of thing. Flip it upside down if we wanted to. A is going to flip it upside down. If A is negative, bam, flips upside down. But it's a pretty straightforward process. Take the angle. The angle, because it's always sine of an angle. And there's our angle, 2 times pi minus x minus pi. Say 2 times x minus pi. Set that equal, or make the compound inequality 0 to 2 pi. So this is going to be the change. So I'm going to divide everything by 2 to start off with. The 2's divide out. I still have 0 is less than or equal to x minus pi, and that's pi. Now from here, I can say, alright, my period, I can take the end point, this is my end point, this is my the starting point, that's what they represent. And I can see now, since it's 0, that my period is going to be equal to pi, which is what we figured out up here. So we can get that from there. And I'm going to add pi to both sides, or all 3 sides. And I'm going to get pi is less than or equal to x, which is less than or equal to 2 pi. Now, what we want to do in this case is we want to take the period, the length, which is pi, and I want to take that pi and multiply by 1 over 4. And that would be pi over 4, and that's going to be my quadrantal interval. So that's going to tell me where my in degrees 0, 90, 180, and 270, and 360 degrees are. So now I'm going to make a chart. I'm going to make a chart. And this chart is going to be the key to everything. I'm going to start at pi. And then I'm going to do pi plus pi over 4. That gets me to my 90 degree angle. Then I'm going to do pi plus 2 pi over 4. Then pi plus 3 pi over 4. And then pi plus 4 pi over 4. Because there are 4 quadrantal angles. And I'll call this my new x. Now pi is equal to 4 pi over 4. So I get pi, that's 5 pi over 4. That's 6 pi over 4, which would be 3 pi over 2. That's 7 pi over 4. And then that's 8 pi over 4, which is equal to 2 pi. Now the rest is just taking advantage of A and C. So I'll do sine of x, which would be, we start at 0, 1, 0, negative 1, 0. And then times A, which would be times my A value is 3. So I'll get 0 times 3, which is 0. 1 times 3, which is 3. 0 times 3, which is 0. Negative 1 times 3, which is negative 3. And 0 times 3, which is 0. And now I'm going to take my C, I'm going to add C to this. So my C was 2, so 0 plus 2 is 2. 3 plus 2 is 5. 0 plus 2 is 2. Negative 3 plus 2 is negative 1. And 0 plus 2 is 2. So those are the values that I'm going to take, and I'm going to plot them on this point. Now, since I went by pi's over 4, here's what I'll do. Is I'll take my graph, I'll draw the graph, and I'll make this pi over 4. So that's 1 pi over 4. This is 2 pi over 4, which is really pi over 2. 3 pi over 4, 4 pi over 4, which is pi. That's 4 pi over 4. 5 pi over 4. 6 pi over 4. 7 pi over 4. 8 pi over 4. And that gets me, well, and that gets me to my final point. Now, I look at this and I say, all right, at pi I need a 2, so pi, there's my 2. That's 1, that's 2, that's 3, that's 4, and that's 5. Sorry about the sloppiness. We all know the reason for that. So it goes 2, then 5, goes up to 5, then back down to 2, then down to negative 1, and back up to 2. So if I draw one period of this, we just draw our sine graph as best as we can. Continue it on. Other things that we see, here's your midline. Your midline is at C. That's our new midline, and that's where the 3 zeros would be. Those are the 3 zeros that would be normally on the 0 part of the graph. This is my amplitude. The amplitude is equal to 3, 1, 2, 3. And that gets me the maximum value of 5. Here's my phase shift. Normally I start here, but I started over to here. So here's my phase shift. and the period goes from here to here. There's my period. The phase shift was pi, and the period itself was pi. So all the different parts are there. And that's really the most straightforward way in graphing the function. So take a look at that. You could graph every single function that way. Doesn't matter what it is. The biggest thing you have to know is this right here. Where does the sign start? Where does the sign finish? And so on and so on and so on. Thanks.